All right, today we're going to take a look at 4/6 arithmetic sequences. All right, so what we're going to do is we're going to find some terms, we're going to graph them, and we're going to write them as functions. All right, so a sequence is just simply a list of numbers. Now, each number is called a term. Here's the thing that you really need to pay attention to. We use the term a of n, where n refers to the position. So this would be a of 1, a of 2, a of 3, a of 4, a of 5, and, well, a of n, because that's the nth position. So where do these numbers come from? So arithmetic sequence is a sequence that has a common difference. So meaning the difference between each number is the same. So if I look here, the difference from here to here is I'm going to add 8. Let me see, does that? Yep, and that continues. So I'm going to add 8 each time. So that means the next numbers in my sequence are 30, 38, and 46. Now, how could I graph this? Well, we're going to use the term as the x value and then give it a corresponding y value. So we've got n and a of n, so this is your x and your y. So this is my first term, second, third, and fourth. So how would I plot that? I'd have 1, 24, 2, 18, 3, 12, and then last but not least, 4, 6. So now, let's graph that. So I have 1, 24, 2, 18, 3, 12, and 4, 6. What do I notice? They're all points on a line. As where this is my n and this is that value. So let's take a look at this last one. Is this an actual sequence? Well, I don't know. Let's take a look. What makes it an actual sequence? Do we have points on a line? Well, if I were to draw a line, yep, that works. Also, another way to check is there a common difference? So remember, this is term 1, 2, 3, 4. So from here to here, 1.5, 1.5, 1.5. So consecutive terms have a common difference. And in this case, that common difference is 1 5/10. So does this represent an arithmetic sequence? You bet it does. Nice. All right, so now how can I write these as a function? Well, let's take a look. So if you remember, this is position 1, position 2, position 3, position 4, okay? So our first term is a of 1, a of 2, a of 3, a of 4. Now, how does that number happen? Well, if this one is 1 and our common difference is 3, my second term would be 4 plus 3. My third term would be 4 plus 3 plus 3. My fourth term would be 4 plus 3 plus 3 plus 3, which is 3 times 3. So now, where do we get all these numbers here? Well, if I'm looking at my nth term, that gives me a of n. So this is always our first value. In this case, that's 4. Now, our d right here, as you recall, is our common difference. And what did I multiply this by? Well, if you notice, this is the third term I multiplied it by 1 less than my term. Here, this is the 4th term. I multiplied it by 1 less from the term. So when I do that, I end up with the first term plus the common difference times 1 less than the term number. So I know that sounds a little bit complicated, so let's break it down one more time. So this is our first term, our common difference, and this is always 1 less than that term number, because if you remember, our first one, we didn't add anything to it. Our second one, our second term here, we only added 3. Our next term, we added 2, which is 1 less than 3. Or we multiplied by 2. Here, multiplied by 3, which is 1 less than 4. So that is where our n minus 1 came from. So we can use this to help us write an equation. So if we take a look, this 7 is our first term. Okay? That's our number written first, so we consider that A1. Now, I want to know what the common difference is. So from here to here, and here to here, and here to here, we subtracted 4. So this is our common difference, which is D. So now, how could I write this? Eventually, I want to find the 30th term. So let's see what we have. So we have A of n equals A of 1 plus n minus 1 times the common difference. So this is going to be the equation for any number that we have. So we've got A of n equals 7 plus n minus 1 times our common difference of negative 4. Now I want to go ahead and multiply that out. So I have A of n equals 7 times negative 4n plus 4. Combine my like terms. So I have negative 4n plus 11. So this is my equation here. You can think of it as a function. Now I want to find A of 30. So A of 30 is going to be my A of n. This is what I'm looking at here. So I'm going to replace what I know. So I've got A of 30 equals negative 4n plus 11. Well, this is like a function, so I'm going to replace my n with 30. If I replace it here, I'm going to replace it here. So I have A of 30 equals negative 4 times 30 plus 11. So A of 30 equals negative 120 plus 11. So A of 30, meaning my 30th term, is going to be negative 109. Now, could I have subtracted negative 4 30 times? You bet I could. But if I wanted to find A of the 300th term, that's an awful lot of work just to get to that one. All right, so let's take a look then at our last example, writing real-life functions. Now, if you noticed, I used the word function just a minute ago. All we're doing is replacing A of n with f of n. So let's take a look. Juan saves $12 the first of the year. He will increase the amount he saves each week by $4. So write a function that represents this sequence. Okay, so our first term then, which is A1, is 12. Okay, you can also see it right here. First term, 12. Okay, my common difference here is 4. Add 4, add 4, add 4. So now I can write my equation. So I have f of n equals A of 1 plus n minus 1 times d. So f of n equals A1 is 12 plus n minus 1 times my common difference, which is 4. So I have f of n equals 12 plus 4n minus 4. F of n equals 4n plus 8. Sure looks like an equation of a line to me. Now I want to graph that bugger. So I have 1, 12, 2, 16, 3, 24, 24, and look at that, a straight line. Now, if Juan's goal is to save $68 in 1 week, which week will he get that amount? Well, so my f of n here is 68, and my function was 4n plus 8, so I'm going to replace f of n right here with 68. So I have 68 equals 4n plus 8. Subtract 8 from both sides. 60 equals 4n. Divide both sides by 4, so n equals 15. In which week will he save that amount? My answer here is week 15. Nice job.